Okay, the other sort of thing that I was asked about was about planes and vectors. And what I'm going to do in this first video is talk about things you already know and just talk about how we would represent those in vector notation instead of in your normal notation. And so you are all very familiar with things like y equals mx plus b. So let's say we had y equals 2/3 x minus 4. When you look at this right here, what we really have are two different things going on in the equation. We have a position and we have a direction. So the position is this -4 right there, and the direction is that 2/3 right there. And the 2/3, you'll remember, is our rise over run. Okay. Now, the way that we would represent this in terms of vectors is a little bit different. We would represent the line in terms of its position, its direction, and we'd have a parameter on it. And so let's write this in a vector equation here, and we'll use that as our starting point. If I wanted to represent this as a vector, let's just call it the vector v. I'm going to give a direction arrow on it. What is the vector v? Well, the vector v is made up of two things. It starts out at the point 0, comma, -4. Instead of writing it as an ordered pair, we write it as a column that starts with x and then goes y. And if we have a third dimension, there would be z in the third dimension. We could have a fourth dimension. We can have as many dimensions as you want. You just list them in a column. So that's the beginning of it. And then we add on to that vector the direction. Well, what happens? We go 3 steps to the right and we go 2 steps up. And so we put the x change on top and the y change on the bottom. So it is going 3 steps to the right, 2 steps up. And typically you'll use the letter t just as your parameter. There's nothing special about the letter t. It's just something that you're going to see a lot of authors use is the letter t. And all this is saying is that the points on the line can be generated by this vector equation. So let's do an example. Let's say that t is equal to 0. What does that tell me? That tells me that I start at 0 and -4, and I add 3, 2. How many times do I add it? 0 times. Well, doing something 0 times can cancel out, and 0, -4 is one of the points on our line. If I wanted to try t equals 2, then I would have start at 0, -4, and I would say 3, 2 times 2. I'm essentially moving two slopes over. I can do it visually. I can move 3 steps over, 2 steps up, 3 steps over, 2 steps up. The answer I should get should be 6, 0. Or if I write it as a vector, 6 is the x, 0 is the y. Let's see how it works out with our vector math. When I multiply a vector, 3, 2, by a scalar, 2, I just multiply each of the coordinates. So we have 0, -4, plus 3 times 2, 2 times 2. When you're adding two different vectors, you just add the coordinates. 0 plus 6 is 6. -4 plus 4 is 0. So we get 6, 0. And so we can take any y equals mx plus b line and rewrite it in terms of our vector version of the equation. So let's just show that in general here, that if we have y equals mx plus b, and if m equals, let's just say we have rise over run. I can't use the letter r, so I'm just saying rise over run is I over u, rise over run. So then what can I write? I can write my vector as b is the y-intercept. That's just kind of what we do in high school algebra, 0b, plus rise over run actually gets flipped over. U over I is the vector. There we go. Okay, so that's just doing things in 2 dimensions. There's really nothing fancier in higher dimensions, but I will show you in a separate video how to represent higher dimensional lines as a vector equation. Oh, I forgot to mention that if you have t being a negative number, something like t equals -1, then your line just runs backwards. And so I would end up at 0, -4, plus -3, -2, getting me to the point -3 over -6, and that's just going the slope backwards. You can see it would get down there. -3, -6 would be right there. Okay, so in the next video, I will do a three-dimensional vector equation.